Hi, my name is Alexis and I will be showing you how to do questions 27 and 29 on page 551 of our textbook, and it is regarding exponential growth and decay. So the first question we are doing is number 27, and it says the population of a town with an initial population of 60,000 grows at a rate of 2.5% per year. So the first thing it asks us to do is create an exponential function. So for this function, I have written down up here, Q equals the accumulated balance, Q to the 0 equals the starting principal, R equals the interest rate, and T equals the number of times the interest was paid. So I took Q to the 0 was 60,000 for the initial population. R is 0.025 since the percent per year was 2.5, and T, the number of times the interest was paid, is going to be 1 through 10. So the next thing we need to do after we make the function, which I have here for each, is make the chart. So that's this. So Q equals 60,000 plus 1 times 1 plus 0.025 equals 61,500. So I went ahead and I did that for each number through 10. So to the second power, it is 63,037.5. To the third power, it is 64,613.4. To the fourth power, it is 66,228.8. To the fifth, it is 67,884.5. To the sixth, it is 69,581.6. To the seventh, it is 71,321.1. To the eighth, it is 73,104.2. To the ninth, it is 74,931.8. And to the 10th, it is 76,805.1. So now that I have all those numbers, I need to make a graph. So on the next page here, not good at drawing, but this is what I did. So since it is growth, each year it grows by 2.5%. So I made a chart showing how many years and at what rate it is growing. So that's that. So for question number 29, it says a privately owned forest that had 1 million acres of old growth is being cleared at a rate of 7% per year. So the first thing we had to do was create the function, which the function would be Q equals 1 million times 1 minus 0.07 to the T, which is the number of times it would be paid per year. So since this one is decay, instead of adding, we are subtracting the rate at which it is cleared. So then it ends up being Q equals 1 million times 0.93 to the T, so T being the number of years. So I went ahead and did the same thing. Q equals 1 million times 0.93 to the first equals 930,000. To the second, it would equal 864,900. To the third, it is 804,357. To the fourth, it is 748,052. To the fifth, it is 695,666. To the sixth is 646,990. To the seventh, it is 601,701. To the eighth, it is 559,582. To the ninth, it is 520,411. And to the 10th, it is 483,982. So with all that information, I can make my graph here just like I did for the last one. So since it is decay, you will see that the numbers start at the low end like they normally do and go up until we hit 940, which is just a little higher than the amount that we had for the top number. And I go from the first year to the 10th year. So since it's decay, it starts at the top and it goes down each year, versus growth, where it grew each year.